We've all seen it, right? AI video generation has just exploded. You type in a single prompt, and boom, you get these incredible cinematic scenes that look almost too real. But what happens when we go beyond just making cool-looking videos? What happens when we ask these AIs to actually simulate our physical world? Can they really, truly understand the basic laws of physics? Well, that's the massive question we're digging into today. Okay, so here's our game plan. First up, we're going to tackle what's known as AI's reality problem. Then, we'll introduce a new reality check called R-Bench and see how today's top models actually did on it. After that, we'll get into RovidX, which is a huge new databank designed to solve this very problem. And finally, we'll wrap up with what this all means for the future. Just take a look at this. The prompt was super simple. A single-arm robot closes an oven door. And, the AI kind of gets the gist. But the execution? The robot's arm is, well, it's just floating in pieces. This isn't just a tiny mistake. It's a complete failure to understand that, objects are solid and things are connected. And this right here, this is the core of the problem. And that brings us right into our first section, AI's reality problem. See, there's this massive gap between making a video that looks good and one that's physically correct. For a movie or a meme, who cares, right? But if you're talking about robotics or trying to simulate the real world, physical accuracy isn't just nice to have, it is everything. This slide just lays it all out, crystal clear. On the left, you've got what all the current tests and benchmarks for AI video focus on. Stuff like visual quality, frame clarity, that cinematic feel. But look at the right side. That's what they're totally missing. Did the robot actually do the job? Did its movements make any physical sense? Basic stuff, like did it obey gravity? So, to tackle this head-on, a team of researchers from Peking University and ByteDance basically said, okay, the tools we have are not good enough. We need to build new ones. Tools that could properly measure and eventually help solve this physical reality problem in AI. And this leads us straight to their first major innovation, R-Bench. The best way to think about it is like a brand new, much tougher reality check for AI. It's like they built a better ruler, one that's not designed to measure how pretty a video is, but how physically intelligent it is. And yeah, looking at this, you can tell R-Bench isn't just some simple little test. It's this super comprehensive benchmark. We're talking hundreds of really carefully designed test cases across all sorts of different tasks and different kinds of robots. The whole point is to put an AI's grasp of the physical world through a really tough workout. So what is this new ruler actually measuring? Well, it boils down to 4 really key things. First, task completion. Plain and simple. Did the robot do what you asked it to do? Second, physical plausibility. Did it follow the basic rules of physics? Third, structural consistency. Did the robot's body stay in one piece, or did it suddenly grow a third arm halfway through? And finally, action completeness. Did it actually follow all the necessary steps to finish the job? Let's just zoom in on physical plausibility for a second, because this one is a huge deal. This metric is specifically designed to catch all those crazy, reality-breaking mistakes we saw earlier. Things like floating parts, objects just phasing through each other, or a robot moving something without even touching it. These are the dead giveaways that an AI just doesn't get how the physical world works. All right, now for the main event, putting these AIs to the test. The researchers took this new, super tough benchmark, and they threw it at some of the world's most advanced video generation models. So how did they hold up? The team tested a whopping 25 different models, a mix of everything from open source to commercial, and even some AIs built specifically for robotics. So the big question is, how did these heavy hitters do when they finally had to take a real physics test? The results were pretty wild. The top spots, yeah, they were taken by big commercial models like WAN 2.6 and CDance. But look further down the list. Sora V2 Pro, which is famous for its stunningly cinematic videos, landed way down in 17th place. And those models built just for robotics, they were almost at the very bottom. And this points to the first huge insight from this whole thing, something the researchers call the media simulation gap. It turns out models like Sora are absolute geniuses at making things look good. They're built for media, for entertainment. But that skill just doesn't mean they're good at accurately simulating physical tasks. Making a video smooth is not the same thing as making it physically correct. The second big takeaway, it's all about what they're calling cognitive bottlenecks. Pretty much every single model, even the best ones, really struggled with tasks that needed any kind of logic or reasoning. And they found it was way, way harder for them to generate delicate, fine-grained movements, like a robot hand carefully picking up a tiny screw, than it was to generate big, simple movements, like a robot dog just walking across a room. Now, you're probably wondering, okay, but how do we know this new benchmark is any good? How do we trust it? Well, this number right here is the proof. The researchers found a 0.96 correlation between our bench's automated scores and what human judges thought. I mean, that is an incredibly tight match, and it proves that this new ruler is both effective and very, very accurate. Okay, so our bench is the final exam, but how do you help these AIs study for it? And that brings us to the second half of this amazing solution, RovidX. Because let's be honest, you can't learn physics without the right textbook. To get these models up to speed, the researchers didn't just build a test. They also built the ultimate study guide. RovidX is a massive, incredibly high-quality dataset of robot videos, and it was designed from the ground up to teach AI the fundamental principles of physical interaction. And when I say massive, I am not kidding. RovidX contains 4 million annotated video clips. That's right, 4 million. It is the biggest open-source data site of its kind, built specifically to train this next generation of physically aware AI models. And creating this thing was a serious operation. First, they collected millions of videos from all over. Then, they used AI to filter them for quality. After that, they used another AI to break down and caption every single action in every clip. And for the final touch, they added in physical properties like depth and motion. It's an unbelievably rich resource. So, the million-dollar question, did the new textbook actually work? Oh, yeah, it worked. As you can see on this chart, when the researchers took existing models and trained them a bit more on the new RovidX dataset, their scores on the R-Bench test shot way up. The new study guide is a huge success. So when you put this all together, what does it mean? Well, it's paving the way forward. By creating a better way to measure the problem and a better way to teach the solution, these new tools are seriously speeding up the journey to what many are now calling physical AI. So if there's one thing to take away from all this, it's this simple idea. A better ruler, which is our bench, lets us finally accurately measure an AI's physical intelligence. And a better textbook, RovidX, gives us the material to actually teach it. And together, they create this really solid foundation for building the next generation of AI that can actually exist and act in our world. You know, there's a quote from the paper that just absolutely nails it. They say, the field is moving to a new stage, physical AI, where the whole point isn't just to make pretty videos anymore. The new goal is to create models that can truly understand and simulate our complex, messy, physical world. It's a huge shift from just visual flair to actual physical intelligence. And that leaves us with one last, kind of mind-bending thought to chew on. The line between what's a simulation and what's reality, it's getting blurrier every day. If an AI can truly master the physics inside of a video, what's really stopping it from mastering physics in the real world? You know, we've all gotten pretty used to AIs answering simple questions. But things are evolving, and fast. They're becoming something way more powerful. Think automated research assistants. These things can browse the web, analyze images, and write up complex reports, complete with citations. So the big question is, are they any good at it? And maybe more importantly, can we actually trust them? Okay, let's get right into it. We're talking about a whole new class of models here, called Deep Research Agents, or DRAs for short. And no, these are not your basic chatbots. They're being built to tackle those big, open-ended, long-form tasks, pretty much exactly what a human researcher would do. But this, of course, brings up a huge question. Can an AI really pull this off? I mean, can it truly do deep research that uses multiple sources? And not just text, but also understand the charts, diagrams, and images that are so critical in the real world, and then weave it all into a report that's actually trustworthy? That's the core challenge we're going to explore today. Just take a look at this. This gives you a perfect idea of what we're talking about. This is not a simple question. The user gives the AI an image, these eye drops, and then describes their symptoms. From there, the AI has to do a ton of work. It has to identify the product, understand the medical context, search for alternatives that are available in a specific city, and then write a helpful cited response. It's a really complex, multi-step job that mixes both text and visuals. And here's the problem. Most of the tests we have for AI, well, they either focus on text-only research or really simple visual questions and answers. There's been this massive blind spot, a way to really rigorously test if these AIs can handle both text and visuals together in one single end-to-end research project. Well, until now. So to solve this problem, a team of researchers from Ohio State and Amazon Science created what is essentially a new gauntlet for AI, a really brutal comprehensive test designed to push these research agents to their absolute limits. It's called MMDR-Bench. Okay, let's break that name down. It's the very first benchmark that's been built from the ground up to see if these advanced AIs can produce long, properly cited reports by pulling evidence from both text sources and from images. What this diagram shows so well is that this isn't just a test of one single skill. It's the entire pipeline. You can see all the different inputs on the left, searching the web, perception, planning, and it all leads to that final report on the right. The benchmark evaluates the whole process from start to finish. And this test is seriously comprehensive. We're talking 140 different tasks, all meticulously crafted by PhD-level experts spanning 21 different fields. The tasks range from everyday stuff like comparing two products all the way to deep technical analysis that requires understanding really complex diagrams. So how in the world do you fairly score an AI on a task this complex? I mean, it's not like there's a simple right or wrong answer. The researchers came up with this really sophisticated evaluation pipeline, which we can think of as a panel of 3 specialist judges. All right, let's meet our judges. First up, we have the style judge, who's all about the writing quality. Then comes the fact checker, who verifies every single source. And finally, we have the visuals expert, making sure the AI actually understood what it was looking at. Our first judge is called Flay. You can think of Flay as the writing critic on the panel. It scores the report on things like, is this easy to read? Does it actually offer any real insights? Is it well-structured with clear sections? Basically, is this a quality piece of writing? Next up is Trace, and honestly, this is probably the most important judge of all. Trace is the super meticulous fact checker. It goes through every single claim the AI makes and checks. Is this statement actually supported by the source it cites? No shortcuts, no making things up. Just the facts. And our third and final judge is Mosaic, the visuals expert. Now, this is the really crucial new piece of the puzzle. If the AI report says the chart shows a 20% increase, Mosaic goes and looks at the actual chart image to confirm it. This makes sure the AI isn't just hallucinating or making up details about the visuals. Now, what's really crucial here is how these scores are weighted. Take a look at this. A full 50% of the final score comes from the fact checker, Trace. 30% comes from the visuals expert, Mosaic. That leaves only 20% for writing style. This makes it crystal clear. The benchmark cares way more about truthfulness and accuracy than anything else. Okay, so the gauntlet is set, the judges are ready. It's time to see how today's top AI models actually did. Let's take a look at the final report card. The researchers put 25 of the most advanced AI systems out there through this grueling test. We're talking single-modal models, multimodal models, and those specialized deep research agents. So who came out on top? And here it is, the overall leaderboard. As you can see pretty clearly, there's a huge spread in performance. The top models are definitely pulling ahead of the pack, but even the very best score is only around 50 out of 100. That tells you just how incredibly difficult this test really is. Let's zoom in on the top contenders, because this is where it gets interesting. The overall winner was a model called Gemini Deep Research, scoring a 49.41. It won largely because it excelled at evidence quality. That's that all-important fact-checking score. Right behind it is Gemini 3 Pro. But what's really fascinating to me is that GPT-5.2, while it scored lower overall, actually got the best score for visual grounding. It was the most reliable at correctly interpreting visual evidence. This just goes to show you there are real trade-offs between these different models. But the leaderboard is only half the story. The most valuable part of this research isn't just about who won, but about what we learned, the fundamental challenges that these AIs are still facing. First up, and this is a big one, just giving an AI eyes doesn't automatically make it better. In fact, adding that vision capability can sometimes even hurt its performance. The models would often misread fine-grained details, numbers in a table, dates on a chart, and that would introduce brand new errors that a text-only model wouldn't have even made. And this leads us to the second key finding, which is a real paradox. The more advanced agentic systems, the ones that are better at digging up information, were actually 4.3 times more likely to make errors mixing up who did what when it came time to write the final report. So they find the right facts, but then they get them all jumbled up during synthesis. The third major takeaway is this. While all those tools and fancy agent systems are helpful, they can't make up for a weak foundation. At the end of the day, the raw power and intelligence of the core AI model is still the most important factor for success. A great research process just can't save a mediocre brain. And all of this really leads us to one final critical question. Our AIs are becoming these incredibly fluent writers, right? They're capable of producing eloquent, well-structured reports. But as they start incorporating visual information from our complex world, this research really shows we have to stop and ask, can we truly trust what they see?
You know that feeling, right? You spend years in language classes, you can ace the tests, but the second you have to actually speak to someone, you just freeze up. Well, today we're going to take a look inside an AI language app called Praktika. We're going to explore the pretty amazing tech it uses to bridge that exact gap, to help people finally build real speaking confidence, one conversation at a time.
This quote from one of Praktika's co-founders, Adam Tureyev, really just hits the nail on the head. For him and for so many others, learning a new language isn't just a hobby. It's not about grammar, it's about opportunity. And that very personal drive is the engine behind all the technology we're about to dive into.
So what is the core problem they're actually trying to solve here? Well, it's something the founders of Praktika knew all too well from their own experiences after immigrating. They call it the real-world fluency gap. And it's that incredibly frustrating space between knowing a language and being able to use it with confidence.
I think this is going to feel really familiar to a lot of you. On the one hand, you've got all that classroom learning down pat. You can read, you can write, no problem. But on the other hand, you're in a real-life meeting or just trying to order a coffee, and the words just get stuck. This is the exact gap they decided they had to close.
And that's where Praktika comes in. It was literally built from the ground up to be that bridge. It's for all the students, the professionals, the immigrants, anyone who needs to turn all that textbook knowledge into actual, practical, everyday speaking skills.
Okay, so how did they actually build this bridge? Well, it wasn't about just creating one single clever chatbot. No, they went way beyond that. They built a whole multi-agent system. So you should think of it less like a single tutor and more like your own personal team of AI specialists.
And here's what that team looks like in action. You've got 3 specialized AI agents all working together for you. There's the lesson agent, the student progress agent, and the learning planning agent. Each one has a totally different job, but the key is they're always talking to each other. So let's break them down.
First up, the lesson agent. This is the AI you're actually talking to, face-to-face, so to speak. Its whole purpose in life is to make the conversation feel completely real and unscripted. It's not just following some rigid plan, it's mixing a tutor's personality with your own goals to create a totally natural back and forth.
Now, while you're chatting away, this agent is working silently in the background. The student progress agent is kind of like your personal performance coach. It's constantly tracking your fluency, your accuracy, and any little mistakes you might be making over and over again. And all that data creates this constant feedback loop for the other 2 agents.
And finally, you've got the long-term strategist, the learning planning agent. This is the big picture thinker. It takes all that data from the progress agent and uses it to adapt your entire learning path. It's the one deciding what you should work on next, making sure your journey is always as efficient and personalized as it can be.
Okay, so a team of AIs is super cool. But how do you make it actually feel, well, human? This is where the magic really happens. Let's get into the subtle art and design that makes these conversations feel less like talking to a program and more like a real live exchange.
I mean, just think about it for a second. What's the real difference between talking to a person versus talking to a basic chatbot? It's not always about what they say, is it? So often it's about how and when they say it. It's all about the timing.
And here it is. This is the secret sauce. Most AI systems try to guess what you're going to say and load up all the context ahead of time. Praktika does the exact opposite. It listens to you completely, then it processes what you said and pulls up what it needs to respond. It's a subtle shift, but it's so powerful because the AI reacts to what you actually said, not what it thought you were going to say.
This quote from the founder just nails why this is such a game changer.
The AI responds to your mistake right now, in the moment. That little difference in timing is everything. It's what makes the tutor feel attentive and present, instead of robotic and scripted.
So, we've seen the clever architecture, we've seen the subtle psychology. But does all this fancy tech actually lead to better results? For the learners and for the company? Well, let's look at the numbers. I mean, just look at how fast this technology has evolved. It's incredible. They went from the first models that made conversations just start to feel real to a new generation that brought in more reasoning and even emotional nuance. And now, they're at this multi-agent system that can handle seriously complex reasoning at a massive scale, making everything better and more efficient.
And here's the proof in the pudding. When they rolled out this new, more attentive memory system, day one user retention, so the number of people who came back the next day, shot up by 24%. That is a huge number. It proves that users didn't just notice the change, they loved it. It made the whole experience stickier.
And it wasn't just retention. Pretty much across the board, every important number started going up. More people finished the setup process, more people converted from a free trial to a paid plan, and revenue literally doubled in just a few months. It's clear proof that better tech created a better experience that people were willing to pay for.
So, what's the big picture here? When you zoom out this whole journey, from a personal frustration to this super sophisticated AI system, it's about so much more than just mastering verb tenses. It's really about what that new ability unlocks inside a person.
This final quote just captures the mission perfectly. The end goal here isn't fluency, not really, it's confidence. The technology is just the tool. The real end goal is to empower people, to help them feel capable and totally comfortable when they speak, no matter where they are in the world. And that leaves us with a pretty fascinating thought to end on. This technology was built to learn a language, sure, but that core idea, an AI that truly listens before it responds, you could apply that to so many other things. So, what could you learn? What could you overcome? If you had a dedicated teacher for anything that was always truly listening.
For decades, when you asked what makes a car safe, the answer was pretty simple, right? It was all about how well it protected you in a crash. Well, that entire definition is being flipped on its head. So let's dive into this massive shift, a shift away from just reacting to an accident to actually preventing it from ever happening in the first place.
Think about it like this. For years, it was all about what you see on the left here, passive safety. We're talking about stuff like heavy steel frames, airbags, those clever crumple zones, all incredible engineering designed to help you survive a crash. But what if the crash never even happened? That's where you have to look to the right side of the screen. The focus now is on active safety, technology that is constantly working to avoid the collision altogether. You've probably heard of automatic emergency braking or lane keeping support, but the real game changer, it's that predictive AI assistance.
And look, this isn't some pie-in-the-sky idea for the future. This shift already has a champion. In fact, looking ahead to 2025, Europe's biggest safety authority, Euro NCAP, already crowned its top performer, the Mercedes-Benz CLA. And the reason why is absolutely crucial. It's because it mastered both sides of that safety equation. It's built to help you survive a crash, and it uses powerful AI to help you avoid one in the first place.
So, what does it really mean to be the new safety champion? Well, this award from Euro NCAP, an organization that's been the gold standard in Europe for almost 30 years, it's a huge signal that the rules of the road are literally changing. It's not enough to just have a strong frame anymore.
And hey, you don't just have to take my word for it. The CEO of Mercedes-Benz, Ola Kalanius, he put it perfectly. He said that getting a perfect score today requires a state-of-the-art driver assistance system. The message there is crystal clear. These advanced AI-powered systems, they're not a luxury add-on anymore. They are absolutely essential to being considered the safest car on the road, period.
Which, of course, brings us to the really big question. What is this technology? How does an AI co-pilot actually work? Let's pop the hood and really take a look at what's powering this whole revolution. Okay, so at the very heart of this system is a platform called NVIDIA DRIVE AV. Now, what's so fascinating about this is the key phrase here, dual stack. See, this isn't just one single system trying to do everything. It's actually two completely separate systems working together in harmony to be both incredibly smart and fundamentally super reliable. The best way to think about it is like the cockpit of an airplane. You've got your skilled pilot. That's the AI driving system. It uses artificial intelligence to see the world around it and navigate all the messy, complicated, unpredictable stuff that happens in real-world driving. But right there next to it, you've got the ever-vigilant co-pilot. That's the classical safety stack.
It's constantly providing backup, running checks, and making sure the basic, unbreakable rules of safety are always being followed. It's that redundancy, that pilot and co-pilot working together, that creates such an incredible safety net.
And this whole dual-stack system, it doesn't just exist in a vacuum. It's built on this incredible foundation called NVIDIA Helos. And this isn't just about software code, it's a complete safety ecosystem. Those guardrails you see there, that just means there are super strict, documented rules for everything, from the hardware and software to the tools and development processes. It ensures safety isn't just some feature tacked on at the end. It's baked into the system's DNA from the very beginning.
Okay, I know, this all sounds incredibly advanced. But that leads to what is maybe the single most important question of all. How can we actually trust it? How do we prove that a system this complex is genuinely safe and reliable when it's out there on the road with us? Well, the answer comes down to tough, independent validation. This is not about a company grading its own homework. As you can see here, you have these internationally recognized bodies like TÜV Süd and TÜV Rheinland certifying the system against the toughest standards in the industry. And see that internal rating? ASIL 26262 ASIL D? That's the highest possible grade for automotive functional safety. You can think of it as the absolute gold standard for preventing critical failures. This shows without a doubt that the technology has been put through the ringer to meet the highest safety levels possible. Certifications are one thing, for sure. They prove the system is built correctly. But what about the real world? Driving is chaotic. It's messy. It's totally unpredictable. How in the world does an AI learn to handle those one-in-a-million moments? A deer jumping out at twilight, or a car blowing through a red light in a downpour. How do you even begin to train for that? The answer is a number that is, well, it's almost impossible to really wrap your head around. We are talking about billions. Billions of miles driven inside hyper-realistic virtual worlds. By using these incredibly powerful simulation platforms, developers can train the AI on all sorts of rare, dangerous scenarios over and over and over again. These are the kinds of events that are way too risky or just too rare to ever test for in the real world. It's how this AI co-pilot gets a whole lifetime of driving experience before it ever even hits the pavement.
So when you put all of these pieces together, what does it all add up to? Because this technology, it isn't just about one car or one award. It really represents a fundamental redefinition of the relationship we have with our vehicles. So let's take a quick look at what this really means for the road ahead.
So after all of this, what's the one big takeaway here? It's this. The very definition of the safest car has changed for good. It is no longer just the vehicle with the best airbags or the strongest frame designed to protect you in a crash.
It's the one with that intelligent co-pilot on board that sees the road, that understands the risks, and actively helps you avoid that crash from ever happening at all. That is the new benchmark for safety.
And that leaves us with a really fascinating final thought. For our entire lives, we've been the sole pilot of our car. But now, we're starting to share the cockpit. So, as our cars become more and more like our co-pilots, you have to wonder, how will our fundamental relationship with the act of driving itself change forever?